Started last time talking about having imported data, which we haven't talked about yet. We'll talk about next week. You often want to do some sort of transformations on data, and what are the various transformations that we might want to do? Well, we're going to use the dplyr package, and I think those who were here also installed the NYC Flights 13 package. So if you weren't here, you might quickly install that and then load it and load ggplot.
If we downloaded it last week, we don't have to redo that, right?
Yeah, you shouldn't need to reinstall it, but you will need to say library NYC flights loaded in. All right, back to this. So that was just to have this big data set called flights. It's got 330,000 rows, so not something you'd ever want to look at all by itself, and 19 columns. So if you're, let's see, dplyr will, by definition, make sure Tibble is installed and sort of loaded in the background. So when you try to look at this by just saying print flights, oh, I didn't load dplyr, so it's going to try to print all 30,000 rows.
Oh, God.
Sorry, 300,000. Okay, so stop. Library dplyr. All right, so now print flights. It's a much nicer looking thing. So as a Tibble, it will print so that it fills your screen, and any row, it will tell you how many rows it couldn't fit on the screen and how many columns it couldn't fit on the screen and what the names of those columns are. It tells you what the different sort of data types are in each of those columns, int and double, int and dbl, meaning their numbers. dbl means that just at some point in that column, it encountered a number with a decimal place in it. So that actually might be one way to check your data entry. If there's like month or day where you don't actually expect ever any decimal points, but it's read in as a double, that's a hint that you might check that column for where that decimal point may have come up. But then it also, tells you all the other columns and things. All right, so big data set, probably don't want to deal with the whole thing at once. So there is there are a number of ways to sort of wrangle data, to transform data, to filter to just a subset of the data. There's a function called filter. There's a function called, if you want to reorder the rows and things, which, I don't know, could be useful, I guess. There's arrange. If you want to like cut the number of columns in your data, so filter will generally cut down the number of rows in your data depending on the values that it finds in specific columns. Select will just cut down the columns in your data to a more manageable subset if you have like a huge set of columns. Mutate will create new columns. And summarize, in combination with something called group by, group by will take your data set and sort of virtually cut it up into chunks as defined by some subset of the columns it finds. Summarize can be used in conjunction with group by to then take each of those chunks of data and apply some sort of summary to them. So we'll see that in a moment. Okay, so they all work similarly. They take as their first argument a data frame. The second argument is to talk about what to do with that data frame, and they yield a data frame as the result. So to take the example, if we have this section here, we've got filter flights, comma, month doubles equals 1, comma, data doubles equals 1. So Again, the first argument is a data set. We could name that argument. We look back at our R. If I were to start typing, filter, and it'll have the dplyr. So we see that the arguments there, the first one's called .data. So if we want to actually name the argument, we can say .data. In fact, I'm going to bring over, is it a hotkey to bring over the show viewer packages history, move focus to source? Yeah, okay. So close this, new, make it big. All right, so there's in the, what was in the text of the manual there. I'm going to separate things out like I like them. And again, as I like things, actually name the arguments. But the only named argument in filter is the first one, called data. So it would be forgivable if you didn't include the name there.
It has to be .data.
It does need to be .data. Let's see, what happens if I actually run it like this? It's going to say error something month not a helpful thing. It should have actually said that, hey, I wasn't expecting a named argument called data. But
why do you have the data? Just
so
to keep it straight yourself, or is it to then?
I guess my general best practice is always name your arguments when there is a named argument, a name there to give it. So, for example, these other arguments aren't really named. There's no names to give them. If I look at the help for filter, it just says ...
Okay.
So, which means that you can give it further arguments, but they don't have names associated with them. But yeah, we'll actually encounter a scenario at the end where you don't have this there at all, but that's so. All right, so if I just run this, what is it going to do? It's going to encounter this row. It's going to say, okay, any sort of things referred to below, I'm going to go and look for them in the flights data set. So when it encounters this month, it's going to know to look in the flights data set for a column called month. Ditto, if it encounters the day, it's going to look for a column in flights called day. And any arguments after the first line saying what data set to look in are arguments specifying sort of selection criteria. So when you have month doubles equals 1, what this is saying is choose those rows in the flights data for which the value in the month column is precisely 1. So January. If I were to just have that, that would be the sole criterion on which things would be filtered, and I get a data set out that is all the data for those days. Interesting, it didn't actually resize. Anyway, so it would give me all the data entries for which month equals 1. But I did have an extra argument here, which is saying day double equals 1. So find all those columns for which day, the value in the day column is precisely equal to 1. And having them both means that both of these must be true for the data to be selected. So running the whole thing with both will yield a data frame that is just those entries on January 1st. So you could continue to put in any number of criteria here, selecting through. Maybe I wanted all the days except for all the days in January, but not the 1st, because maybe we know that that's a typical recovery day from New Year's Eve. So you could use, as we learned in the first class, the not equals to say not that day. And that would select all the other days. So yeah, you can use all the Boolean sort of comparisons that we learned before in order to filter. the data down. Now, so far we've just been doing the filter and it without assigning it the result of this function into anything. So again, the default of var is when you run a function, it has a result, and you're not assigning that result into anything, it by default will just print it to the screen. If instead we say, call it flights2, cool that?
Mine?
Yeah.
I'm just getting an error when I run that syntax. Is it
All right.
because it's selecting the wrong filter? It
Well,
says unused argument that equals flights.
Do you have dplyr? Aha, so you hadn't actually run that line, and therefore there is another command called filter that's already available in our, when you load up our, that's provided by the stats package. So yeah, it won't give you the expected error of, I can't find this function, because it will find this other one, but it will say, hey, I don't understand that, that you have this thing called data here. So anyway, so when I actually do supply an object to sort of be the container that accepts the result of this call to filter, nothing gets printed, so at which point I would need to say print filter or flights2 in order to see on screen what that data set was. But usually seeing the sort of filtered data on screen isn't that useful. It's still 842 rows. More useful, though, is to save it so that you can later do more computations on it. So maybe you filter by one thing, and then you do some more computations. Let's take a look at some of the other functions you could use. The filter area, or the filter section in the book.
Why did you want to put flights too?
I was demonstrating that you generally, when you're running these things, the book just runs them and shows you the output. If you're actually doing this in a script where you want to use the reason why you'd be applying a filter is because you then will want to do something to that data later, in which case you'd want to store that data away, the result of that filter away into something that you then can do more things on. So, in the, keeps wanting to say manual, textbook here, they go into quite a bit on like the logical operators because, and doing the comparisons, because at this point in the book, the reader hadn't been exposed to that. You guys have. So skipping down through, we should get to arrange. Now, I guess sometimes I look at my data. So arrange is really for sorting like what rows come before what other rows. Since most computations don't rely on that, on the order of your data, so a mean is the same regardless of what order of the data is and things. That's it's not super useful. Oh, I can think of a way that's useful. If you're running some sort of running difference, what would be a good example? Like a session-to-session difference in something. You'd want the data to be ordered in the order of session. So you'd want to make sure it's sort of ordered that way in the first place.
What if it's longitudinal data?
Well, I just used that example, but even in that example, you just have session as a column in your data, and you'd have a number indicating session, and the tools that we'll be using won't again require that number to be there. I'll maybe show you a scenario where it is useful. So arrange, let's use the flights data. And it's the same sort of syntax, so let's actually use flights2 to demonstrate sort of the utility of sorting it, of assigning it away. So we'll use arrange dot data equals flights2, and the arguments to arrange, data, are just the columns that you want to sort by. So let's do dep time. Dep time is departure time. I don't know, departure time and air time. That's another column. I actually don't know this data super well. But in the same way that we up here use the flights as data input, assigns the result of this filter on flights to something called flights 2, we'll use flights 2 as data input here and assign the results back into something called flights 3 maybe. And if I want to take a look at it, flights 3 should be that at least in this column where it's dep time, it's sorted. It is sorted sequentially. The other one we sorted by, airtime, is in one of these columns that we didn't actually select for, or we didn't actually see on the screen.
Sorry, so we just sorted it so that it's ascending?
So yeah, so this one's the first ascending thing, this one's the next ascending thing. If you want it descending, you can put this, I think, here actually let me go triple check. Yep. You just put, you use the desk function and put the name of the column that you want to be decreasing order in there.
So can you think, sorry, like how does this one thing ascending and then the next thing ascending? Like how does it do them both?
First it sorts by the one thing.
Yeah.
If it encounters ties, it sorts by the other the next things that you do.
Okay.
So for example, we actually have some ties here. So there's 554, there's 2 of those. So what order should those go in? It uses the next, anything else that you provide as the tiebreaker, and it just goes through them in order in which they're supplied as arguments to a range.
So would this work for instance, I have a data set that has like session number, participant number, session number, block, trial.
Yep.
And like I want it to be, to go in chronological order.
Yeah.
And so you just put it in
You just
order,
keep adding the,
blah,
yep.
blah, blah, and in whatever order you put it in is the order that it'll do that. I found another way to do that, which looks way worse.
yeah.
So I'm going to use that.
Yeah. Yeah.
Is descending the default, by the way?
No, it's
Ascending is default. So going from small values to larger values. Small values at the
Oh,
top.
right. Sorry, I completely had that in my head and called it descending.
Gotcha. So we've sorted by these 2 columns, but in the output here, we're only actually seeing one of the columns because there's so many columns, we can't see the one that I chose somewhat arbitrarily over here as another sorter. We can actually kind of fix that. One way to fix that is to actually only grab the, tell it to subset the data sets so that you only have those columns. So let's create something flights 4 equals select. And it has a .data argument. We want to use flights 3. And then any other arguments it sees here, dep time, air time, are the columns that it will keep. So if we see that, we'll just get those 2 columns, and this will demonstrate that when it hit the 2 ties here, 554 and 554 in the depth time. It broke the ties. It decided which row would go first by looking at the air time. So 116 is smaller than 1550. Ditto when it hit the tie here, 557 and 557. It broke the tie by putting it in order of what it found in the airtime column. So I think, let's see. There's NA somewhere in this data set. Where is it? Missing values are always sorted at the end. That's sort of an important thing. If the thing that you want to sort on has the column that you want to sort on has missing values, those missing values always get put at the end. Trick. Let's see. This one has. Oh no, he's just using an example with. He creates something that has missing values and he sorts on it. Yeah.
If you were to do arrange though in descending values, do NAs still go at the end, or are they treated as like greater than the last number in the?
I think let's actually he explicitly put it there, and in both cases. Okay, so let's walk through this example. He creates a data frame with just a single column that has 2, 5, and NA, and he runs arrange on it with X as the only column you could sort on, and ditto when he puts it in descending order, NA is at the end in both circumstances, so NA always gets put at the end.
Could you have a placeholder character that is essentially it replaces NA and have it sort of the end of the list? Because you can't just put 0 in that case, because 0 would go prior to 1. Is NAN treated in a similar fashion to NA?
Yeah. I think this is the reasonable behavior when you want to sort.
I mean, you could always cut and copy rows if you sorted and wanted the NAs at the top afterwards.
Yeah. Yeah. You could always just create another column that codes whether the value in the first column is NA or not, and sort on that first to put the NAs at the top.
Yep. Could do that too. So many ways.
Mm-hmm. I don't find much use for either arrange or select because I'm not literally visual. I'm not looking at my data in this way. If I'm looking at my data, it's usually in a graphic or I'm doing some computations on it, and in which case the order of things and what columns are in the data set don't really matter that much, but they're useful to know about. There's some useful also sort of tricks for using select. So you can specify the columns by name. You can also, if you happen to know that there's a number of columns in an order, so year, month, and day, if you put year, day, it's smart enough to know that you want it to be columns year through day.
Is that just based on the order they are in the data set?
Not
that it knows like
month. Yeah, it doesn't know what the word month or day and year mean. It sees that there's a column with this character string and the column with this character string, this character string.
Just if you know you want a chunk, you can just call it.
Yeah.
Okay.
And ditto, if you actually want everything except some subset, you can put that subset inside a parentheses and put a negative on it. You could, here, let me actually go to R and maybe be a little bit more explicit about this. I'm going to copy this arrange here and put it down here. And I'm not going to assign it into anything. I'm just going to show on screen. Not arrange. I want to use select. So if I'll select on flights, and I say I want depth time I guess it wouldn't make sense to subtract single columns because you either want a big chunk of columns or not want a big chunk of columns. But if you wanted to just take out the dep time column, just the dep time, you could do that. And that would take out the dep time. And if you wanted a chunk, a sequential chunk, you'd do that. If you wanted, like, take out sort of a set of specific ones, dep, delay, that aren't sequential.
I got an error for the
Aha.
depth. Oh wait, no. Okay, never mind.
Okay. So sequential, if you've got a sequential set that you want to get rid of, you use the colon. And all that inside parentheses. But if you want just to take out single ones, you need to enter them on separate lines with the subtraction. So
sequential.
okay, sequential in the order in which the columns are arranged here.
So from departure time all the way to departure delay, everything
Yeah.
will be removed.
Yeah. So
And leaves the rest, right?
Yep.
So as opposed to the other.
yeah. So without the parentheses and subtraction, this would keep just the columns dep time to dep delay and take out everything else. If I put parentheses around it and I put a subtraction at the front, this would take off just those ones. Now, if you have like a bunch of similarly named columns, you can use some sort of string parsing functions to grab them all without having to enter them by hand. So if you had a, let's say, starts with, and this says ABC, so let's actually use that. Again, I'll just do it on screen here. If I say starts with, and in quotes, dep, it should get rid of dep time, dep delay, as well as any other things that start with dep. Let's see. Let's run it.
So that gets rid of those things?
Oh, aha, that selects them.
Yeah.
I have to put a negative at the front of the whatever's there to get rid of them. Good eye. So notice there, it kept the sketch dep time because it doesn't start with dep. So that's a starts with. Ditto, there's an ends with. You can do a contains. And in this case, if I take this subtraction off, that will keep any of the columns that contains dep somewhere. So dep time, sketch dep time, and dep delay. Ditto, you can put in a minus to say don't keep those ones. And matches uses something called regular expression. That's a whole skill in and of itself to learn, so I wouldn't bother with that right now. Usually starts with, ends with, and contains are pretty sufficient for selecting out. And ditto, this isn't super common. This is saying if you put like a character and then a sequence of numbers as the arguments to num range, it auto expands it to, so here it's character X and then 1 through 3. It auto sort of adds the X to each of the numbers on the right-hand side here, so it expands that to X1, X2, X3. If you happened to have columns named X1, X2, X3, it would either select them or anti-select them if you put a subtraction at the front. Not super useful if you don't typically have X1, X2, X3. Indeed, if you had this scenario, you could use starts with to say starts with X. There is a way to rename the columns already existing in your data set if you wanted to. It's the rename function. Let's see. That keeps all the variables that aren't, oh, well, yeah. The default behavior is that it takes this data frame, it renames the column that you've talked about here, but it keeps all the other columns that are there.
Excuse me, say that again.
Rename will take the whatever data you give it. It will, if it finds a column named this, tail underscore num, it will rename it to whatever on the right-hand side of the equal sign. But it will still spit back the data set with all the other columns, just with this column renamed. I wonder, will it give you an error if there's no column named that?
The answer is yes.
Aha, okay. I want to just put it up here. So, just demonstrate that it works in the first place. Run that. It has now a... Oh, I had that backwards. I told you that when it does rename, it encounters something, the second argument here with an equal sign. It creates a new thing. I told you it, well, what it actually does is it creates a new column with this name here and puts into it this column that was over here and gets rid of that column that was over here. So this is the new name. This is the old name. What's on the right is the old name. What's on the left is the new name. But it still returns all the other columns too. So it's truly just a renaming. You can rename a bunch of columns at once in there if you want. So I don't know. Oh, that already exists. Distance already exists in the thing, and I want to. I'm gonna need to use this a bunch to get that really encoded. So notice.
So the left side is the new
New
name,
thing, yeah.
right side is
Yeah. Just you can think of it just like when you're creating new objects, using the equal sign. The thing on the left is going to be a new thing.
But it doesn't actually rename, it just creates a new...
Well,
version.
in the sense that it puts the new thing in the same places where the old thing was, and takes the old thing out, puts the new thing in the same places where the old thing.
Okay.
Like, I have a question. Going
Sure.
back to the starts with thing,
Yeah.
when you put a negative sign before starts with so that you get everything except the things that start with that,
Yeah.
I get an error that says incorrect size 0, expecting 842.
Ah.
Maybe there is.
Is there quotes around the thing that you put inside
Yes.
starts with? Let's see. Wow. Let's see. Flight 2 is a thing.
Should it be arrange or select?
I don't know.
I know I have this. Which I know I can spell.
Starts with starts to.
Does it matter that it's arrange or select?
Yes. Select is what is expecting to
Okay.
use things that have like starts with.
Oh yeah, arrange is for like the ascending.
Yeah. You think that they'd be smart enough to recognize that?
Okay. Thanks.
All right. So where were we? So there's rename. Everything this is useful if you have a handful of variables. You're like, okay. So if you just want to like reorder where the columns are, but still keep everything, and there's a couple of columns where that you have particular interest in, you could use this method where you use select, you say what data frame you want, and then a couple columns that you want to be sort of at the forefront of the data, at the far left of the data frame, so that when you print, you see them. And then when you're done the ones you definitely want to see, you just use the everything command or function, and it will add all the other columns in that data set. So this is like arrange, but for columns.
So everything is like a function.
Yep.
So what can go in it?
I think it's just supposed to be blank. Let me actually see. Is there any arguments that it takes? These functions allow you to select based on their names. So everything. Yeah, you're not really supposed to use it. Yeah, it's a function, but you're not really supposed to supply any value to it. So adding new data. Let's see. What is this one? So in the example here, he's first subsetting flights. So he takes flights, uses select to be like a manageable set of columns. So select again is on columns. He's getting year through day. He's getting all those columns that ends with delay. And he's also getting the distance and airtime columns. So if we copy this and run it in ours, lots of unnecessary space thing. Okay. If I run that, I should be able to say print flights SML, presumably flight small. And I see those are the columns that we wanted, plus the two more. Let's try to give it space to show those. One more variable. All right, so those are the columns that we wanted. Still all the rows, though. Now mutate will create new columns.
Sorry,
that,
can you go back to your code?
oh yeah, sure. Do you want me to expand it so you can actually see? Yeah. So this, again, isn't the really format that I'd want. I usually use equals, and I put the commas at the beginnings.
Okay, thank you.
Okay, so having just, all we've done is made it so that we can kind of see the data decently, all the columns in the data. Mutate creates new rows, or sorry, new columns that are presumably some function of the columns that already exist in the data. So the example he has here, mutate, takes in the data set, and again, all these functions, the first argument is data set, and the second arguments, second, third, etc. arguments are all something to do with the data set. So this mutate will add columns, one column per sort of line per argument that you give it. So this is going to make a gain argument and a speed, sorry, this is going to make a gain column and a speed column. We're talking about flights, so if you've got a flight that has a departure delay and an arrival delay, I guess, does this work? If it's delayed by 10 minutes and it's arriving by, delayed by 20 minutes, 20 minus 10 is how much airtime they gained in how much time they gained in the air. Does that make sense? No. If it's actually, yeah, the way the subtraction is going, it's negative. So if they,
That would just be like how late they arrived at the airport.
well,
And when
imagine
they-
this, if they departed,
It should be opposite. shouldn't
yeah, if they departed 10 minutes late, oh, maybe, no, these are all positive numbers,
it?
so,
Some are positive, some are negative. But doesn't, like, yeah, you wouldn't do that equation because,
It's not telling you anything meaningful.
mm-hmm.
oh wait,
If,
the
There's
delays
like
are minutes,
30
not
minutes.
times, right? The delays are,
Oh.
minutes.
minutes are time.
no, but I mean, not in
No,
like,
no.
not like it arrived at 3:30, like it's
Ah,
how many
yes.
minutes later. Yeah, that doesn't make sense.
So if you
It
That
arrive,
does make sense.
The arrival delay would be one flight ending, it arrived 10 minutes late, and then the departure delay would be how
How
late
late
it had
it was leaving.
departed.
So if the number is negative, it means that it gained X amount of
Mhm.
time in the air. It was planned to take
Mhm.
2 hours.
You-
It took off 15 minutes late and
Mhm.
landed 10 minutes late. It actually gained
Right.
5 minutes on its
Yes,
flight
okay,
time.
that makes sense.
But the way you described it, it would have negative numbers would reflect a gain,
Yes.
which
Yeah,
is a
yeah,
silly.
it's not
You'd,
intuitive.
you'd expect it to be the other way around.
Well, I mean, if it's just
Yeah,
a difference,
you could turn
wouldn't
it
you
in-
expect added time to be positive time, like it's X amount slower. So
Okay,
it's
all right,
minus.
all right. All right, I'm gonna put that in
No,
there.
not at all.
And just for my sanity, I'm gonna say data equals that. I'm gonna put the line as starting with a comma, but this line is starting with a comma. Take off this comma, that's right there. Okay. So if I were to run this, it's just gonna print the screen. So I'm gonna create something, flights SML2. Print flights SML2. So, and speed, pretty straightforward. So it's adding 2 columns. If I had other columns I wanted to add, I could do them all at the same time there. I printed it when it was really small, so now we've got the gain, and the speed is just not shown. Let's see. Can I make that even smaller? Yay! So mutate just adds more columns that are usually some function of the other columns, some combination of the information that's in the other columns. One thing I quite like about mutate is that it's you can refer to columns that you've just created as it goes. So if we have flights SML, it didn't have a gain column, but we tell it to create one. It didn't have an hours column, but we tell it to create one. It didn't have a gain per hour. We told it to create one, but we told it use as sort of in its computation this column that we only just now told you to create in this other column that we only just now told you to create. So it's a word for that. It's sort of evaluating the columns lazily one by one instead of all at once at the beginning.
You can't use mutate to like create a single value, can you? In this fashion.
Try. If you meant like,
if you want to like just get a simple correlation between like speed and the amount of time gained.
so no, mutate is more about
Actual
creating
operations.
sort of no new rows, just creating new columns and sort of doing the computation so that you have sort of an not a unique necessarily, but sort of an entry per row that isn't
Okay, so
constant.
Yeah, you can't just tell it to
Yeah.
insert all
Summary
operations.
is where you are starting to collapse rows into some sort of summary of their contents. Which, if you're saying, what is the correlation between these 2
But
columns,
then you could be looking
you're
at-
collapsing rows on the basis of what's in the
Oh
columns.
yeah, that's why I was saying like single value because technically
Yeah.
you just get
Yeah,
single
so we'll get to summary in a moment. If you had a scenario where, again, you are, for some reason, you don't like to keep the whole data set the whole time, you just want the new columns that you've created, transmute is what you know. So there's mutate and transmute. Mutate will just add the new columns to the existing data set. Transmute will only keep those new columns, so you'll lose all the original columns.
Like every single column, or the columns are changed?
You'll lose every single column that's not created in the call to mutate.
This would probably be useful to sign that to someone if you actually don't care.
Yeah. Yeah, I mean, again, if you are constantly looking at these data sets in your viewer here, or in the console or in the viewer, maybe you'd want to use transmute and select and all these things, but I don't find myself using them that often. He goes through some operators and things that aren't super useful for what we're going to talk about. So now we get into some good stuff. Summaries. Summaries on their own aren't super useful because they'll just summarize the entire data set. So let's take this example. We've got the summarized flights and what we have at the side. Let's actually, I'm going to copy this and put it into my editor so that I can split it up onto different lines. So summarize.data equals flights, delay equals that, and it's a call to mean. The call to mean is supplying 2 arguments. So we've already seen the mean function before and why it's got this na.rm. Na.rm equals true means that whatever it's being given here as the first argument to mean, wherever it sees an na in that data, it's just going to take it out so that it then can actually compute a mean on that data. The default for mean is that this is false, which is kind of nice because if there are NAs in your data, it actually yields a mean that is NA, and that's a signal to you that there's NAs there. In this case, the author of the textbook happens to know that there are NAs, but he wants them removed for the purposes of this example. So we need to turn that NA equals RM equals true. So what's happening in this? Again, we're giving it summarize a data set, and whatever it encounters as arguments thereafter is going to be the creation of new columns that reflect some sort of summary of the original data set. So it's going to look in the flights data set, grab all the values in a depth delay column, take out all the RMs, compute a mean for that, the remaining values, and store that in a column called delay. So if we run this, it's going to then return a data frame with just a single column, a single row reflecting the mean of that entire column of flights.
So then that goes in a column called delay.
Yeah. So if let's create a somewhat more useful things, or I guess just for the purpose of example, if I call this mean delay, I'll copy this whole thing, paste it.
Do like depth delay mean or something.
You could call it whatever you want. Yeah. Depth delay mean. And if I wanted to do an SD, I'd maybe call it depth delay SD. Instead of mean function, I'd use the SD function. Where'd I lost a parenthesis there. So here I've supplied 2 arguments to summarize after the main data argument. And so I should get 2 columns.
So then there's just one value in each
Because it's taken the
columns?
entire column and computed whatever summary statistic we've asked of it.
So then it just, like, if you were going to look at it, it just goes 12.6, like, all the way down?
Well, now there's just a single data frame that has 1 row. So it's not, it hasn't tried to overwrite anything back in this flights data set. It's creating a new data set that just has one row. And that can be somewhat useful if you wanted to get sort of, okay, what is the mean for the entire data set for something? More useful is when you have, usually we have data sets where there's some natural grouping of the variables. So subject might be a grouping. And within subject, maybe task might be another grouping. So summarize is more useful when combined with grouping. So usually, so I'm going to take the same example here that I've put the summarize. I'm going to push it down a little bit. I'll call something grouped flights. And put into this thing called group flights the result of a call to group by. Group by being a dplyr thing wants data as its first argument. And put flights. And everything else is a list of variables to sort of use as grouping variables. So if I want month in there, it's going to any subsequent, well actually, let's just run this and create it. So I'm creating this object called grouped flights. It is the result of this call to group by. I happen to know that group by and all dplyr functions will create a data set as its output. So nothing actually gets changed about the output or about the data object when I do that group by. It's just that same flights, but it has added a little bit of like what you might call metadata so that if I then use this grouped flights instead of flights down here, so I'll say grouped flights, summarize will automatically know to, instead of just computing these two values, whatever they are, for the entire data set, it's going to cut the data set into the groups that have been defined in this object and spit out, well, we asked it to be grouped by month, so it's going to give us the mean per month, the mean in SD per month. And, oh, I need to expand it, the view a little bit here. So we have the grouping variable, or variables, we only used one, but so month is in this column over here, and there's the mean in SD for each of those entries there, each of the months.
So it has the 1, 2, 3, that's just like the row numbers, and then it has 1, 2, 3 like the months.
Yeah. So these are those somewhat annoying row numbers here, and directly under the month, sort of right aligned with the word, with the column name here, is the entry in that column. Pull that back? Yeah, sure.
When you do the group by, it's just going to basically create groups based on the level of whatever argument you put in.
Yeah.
If you want, can you subset the list of levels that you include? So say in the example of subjects, you had a subject that you wanted to remove for X or Y or Z purposes at this stage, that isn't necessarily a bad place to do it, is to say, like,
well, I would do that.
Take month less, like,
Yeah, I would do that as a filter step before the group by. We'll see, well, not now, because next class we'll see the sort of examples of chaining these operations together and how it can actually create a nice human readable sort of path of analysis But
I was just thinking of-
in that sort of stepwise process, the procedure, the task that you're describing is better achieved earlier when you're doing the filtering rather than doing grouping. You're trying to
I
somehow
was just thinking
subset.
of ways to try and make fewer lines of code to do the same thing.
Yeah.
Because if all you're doing is sorting a data frame, you're not actually altering any values in it. You're just putting them in different places.
But if you're saying you want to just ignore one level of something, or
Yeah, I mean, you could do a filter command.
Yeah.
I was thinking that you could also do that. But that's
there's often a conflict between parsimony of code and human understandability of code.
I'm writing from the island.
yeah. So yeah, that's all we'll talk about today. We'll sort of go probably a little bit back through some of this. So next day we'll talk about chaining these together, and as we do that, we'll probably refresh some of these ideas. But, yeah. And then next week we'll be actually reading in data, and how that can be a pain in the ass sometimes. And then we'll hopefully be on to actual stats.
Does R read SPSS files out of curiosity?
Yeah. Oh yeah.
Oh my god.
Oh yeah.
I was gonna say, like, that's all